So what is the first question, children? First one of the first Roman. What is the common factor of 3 and 7? Common factor of 3 and 7 is how much? As you know, 3 and 7 are prime numbers. Its common factor is 1 only. Its common factor is 1 only. Therefore, factors of 3, 1 comma 3, factors of 7, 1 comma 7, as 3 and 7 are prime numbers. So here only 1 is common factor. Therefore, common factor of 3 comma 7 is equal to how much, children? 1. It is given in the first option. Okay, children. Then what is the second question, children? What is the greatest common factor of 40, 56 and 60? What is the greatest common factor of 40, 56 and 60? Greatest common factor of 40, 56 and 60. So, of course, for finding HCF, we have 3 methods are there, children. First one is by writing all common factors. Second one is prime factorization method. And third one is by doing division method, children. So, if the question is with respect to large numbers, let us depending on division method. If the numbers are smallest numbers, let us go back to the factorization. So, what are the factors of 40? What are the factors of 40, children? This is 140 is 40, 1 after 2, 2 20s are 40, 2 after 3 it is not divides. So 4 10s are 40 and 5 is not there. Okay, 5 8s are 40. Between 5 and 8 we have 6 and 7. They are not factors of 40. That's all. So what are the factors of 40? 1, 2, 4, 5, 8, 20 and 40. So these are the factors of 40. What are the factors of 56? Factors of 56. So if you see 156 and 2 28s and 4 14s, 4 14s 56 and 5 is not possible, 6 is not possible, 7 8 are 56. So what are the factors? 1, 2, 4, 7, 8, 14, 28 and 56. Now what are the factors of 60? What are the factors of 60, children? 160 60, 230 60, 415 60, 320s. Three 20s, 4 15s, 5 12s are, 6 10s are. So 6 10s are, 5 12s are, 4 15s, 3 20s, 2 30s, 61s are. So these are all factors of 60, factors of 56, factors of 40. Now identify the common factors, children. 1, okay, 2 also common. Next 4 also there, then 5 is there but not there for 56, 8 is there for first 2 but not there for 60, 20 is there for first and third but not there in second, 40 is there only for first one. So there is no common factors other than these 3. So what are the common factors, children? 1, 2, 4. In that, what is the GCF or HCF? Greatest or highest? What are the common factors, children? 1, 2, 4. In that, what is the greatest? 4. Therefore, greatest common factors of 40, 56, 60 is how much, children? 4. Okay, children. So let us come back to third question. What is the third one? HCF of 56 and 64. Children, already we explained in some models. Here let us do a little bit depending on division method. See how it is. 56, 64. Let us say 56 cancel here one time only. When you subtract, it is 8 times. So by doing division method, what is the process here, children? Here the divisor takes place as dividend. So it is how many times? 7 times. So whenever you get no remainder means 0 as remainder, the last divisor is taken as the HCF. The last divisor is taken as the HCF. So what is the HCF of 56 and 64, children? HCF of 56 and 64 is equal to 8. HCF of 56 and 64 is 8, children. This is the third one. It is given in the first option. And come back to fourth question. What is the greatest common factor of 5, 15 and 125? What is the greatest common factor of 5, 15 and 125? So let us try to write again like factorization method. Factors of factors of 5 are 1 and 5. Factors of 5 are 1 and 5. Then what are the factors of 15? Factors of 15 are 1, 3, 5, 15. 1 15s, 3 5s are. And what are the factors of 125? Factors of 125 is equal to 1 125s and 525s 125. So what are the factors of 125? 1, 5, 25 and 125. Now here let us observe the common factors. So what are the common factors, children? Here let us round it. Here 1, so 1, because of course 1 is the common factor for any number, and then 5 also. So that's all, there is no third factor for the first, we need not to check. So 1 and 5 are the common factors. In that, which is the highest, children, or greatest? 5. Therefore the greatest common factor is equal to 5. The greatest common factor is equal to 5. So it is given in the third option, C. So what is the greatest common factor of 5, 15 and 125, children? 5. So fifth one of the first Roman, children. What is the HCF of 5, 10, 35 and 40. 10, 35 and 40 is how much? Actually, children, so far we discussed two methods, division method and by writing all factors. So why can't we go for third method in the same assignment? So let us try to go for, what is the third one? Prime factorization method. So 10 can be expressed as 2 into 5. What is the first prime number? 2. It divides 10 5 times. As 5 is prime, our process is completed. And 35. The first prime is even, so it is not divides 35. So 5 7 times, so it is prime, process completed. Then 40, this is 2 20 times, again 2 10 times, again 2 5 times. As it is prime, our process completed. So 10 means 2 into 5. 35 means 5 into 7. And 40 means, so 2 raised 3 times, 2 raised 3 times and 5 raised only 1 time. So in 10, 2 raised how many times, children? 1 time. Here 5 raised 1 time. In 35, 5 raised 1 time, 7 raised 1 time. In 40, 2 raised 3 times, 5 raised 1 time. Now, if you see how to find HCF of 10, 35 and 40 is equal to, children, whenever you are doing prime factorization method for finding HCF, always try to search where it is common factor. Where it is common factor? Here 5 only common factor. Let us take only the common factor. Now how many times 5 needs to kept here? Let us take the least power. So 5 raised 1 time, here 1 time, here 1 time. Of course 5 raised equal number of times among all the numbers. Therefore 5 taken 1 time only, least. Therefore what is the HCF of 10, 35, 40, children? 5. So it is also given in third option, children. It is also given in third option, children. So question number 5, third option. So one more thing, children. Question number 4 already we discussed as a 5 is the greatest common factor of 5, 15, 125. It is second option. Actually I told third, that is not. Second option. Okay. So let us come back to second Roman. Question number 6. What is the sixth one? What is the HCF of 106, 159 and 265? HCF of 106, 159 and 265 is equal to how much? Let us do the division method, children. Whenever we have more than two numbers, how to do the division method? Let us take any two numbers, 106 and 159. So do the process. Get the HCF of any two numbers. The HCF of any two numbers, again you verify with the third number. So the HCF of first any two numbers is again finding with the third number. The final HCF is taken as the HCF of all the numbers or all given numbers. So it is one time, children. So this is 53. The divisor will take place in the dividend. So it is 2 times, children. So HCF of 106, 159 is equal to how much, children? 53. The last divisor is the HCF of these two numbers. Now again with the HCF, verify with the third number. It is 5 times, children. Again, as it is 0 is remainder, so the last divisor is taken as the HCF of, therefore HCF of 53 means HCF of first two numbers with the third number is 53. Therefore HCF of 106, 159 and 265 is equal to 53. HCF of 106, 159 and 265 is 53. So this is the answer for sixth question, children. So let us come back to question number 7. What is question number 7, children? The HCF of 28, 35, 49. The HCF of 28, 35 and 49 is so let us go back to any method. See, for example, what are the factors of 28? 128 28s, 2 14s 28, okay, and 4 7s are 28. 1 28s, 2 14s, 4 7s. These are the factors of 28. And what are the factors of 35? What are the factors of 35? 1 35 is 35, 5 7s are 35. 1 35 is 35, 5 7s are 35. And what are the factors of 49? So this is 1 49s 49s, 7 7s are, as 7 is repeated, writing one time is enough. Now what are the common factors? Now, so what are the common factors among all? So 1 is the common factor. Any other? 7 only next common factor, that's all. So what are the common factors? 1 and 7. In that, what is its highest common factor, children? 7. Therefore, HCF is 7. So this is HCF of 28, 35 and 49, children. In which method we applied here? By writing all factors, children. So let us come back to question number 8. What is the HCF of any two consecutive even numbers? HCF of two consecutive even numbers is how much? Let us take some consecutive even numbers, 4 and 6. Let us do it. Four ones are 4. Remainder divisor will takes place. Then 2 times. So the last divisor is taken as the HCF, that is 2. 4 and 6 are two consecutive even numbers, and similarly 18 and 20 are two consecutive even numbers. So 18 ones are 18, remainder 2, and it goes to dividend, then 9 times. Again the last divisor is taken as the HCF. So what is the HCF of two consecutive even numbers, children? 2. HCF of two consecutive numbers is always 2, children. And our 9th question is, what is who is the famous Greek mathematician who found the division method to find the HCF? We did so many questions, children, by applying division method. Who is the mathematician who found a method, division method, for finding HCF, children? He is none other than the famous mathematician found division method in finding HCF. Who is that, children? He is Euclid. He is none other than Euclid, father of many mathematicians like Pythagoras, Thales, Varahamihirdu, Aryabhatta, so many. Because as Euclid is the father of Thales and other mathematicians, by applying his concepts only, Thales, mathematician who found the sum of all three angles in a triangle is 180 degrees, and everything is he kept under the name of the Elements book. Okay, anyway, so he found the division method for finding HCF. His name is Euclid, children. So what is the last question, children? Whenever we are applying to division method, what is the last divisor? The last divisor is dash of the given numbers. See, whenever we are finding HCF, we know the last digit is taken as the HCF of the given numbers. So this is HCF of the given numbers, children. So that's all. The explanation for today's assignment 5 for class 6 children. Have a nice day and keep working. Thank you.